So let's look here at the pressure depth relationship. First of all, we need to know that one particular pressure that we exhibit that we experience all the time is atmospheric pressure. And so we define atmospheric pressure. So pressure of 1 atmosphere. So this is 1 atmosphere, and that is defined to be 1.013 times 10 to the fifth pascals. That turns out to be about 14.7 pounds per square inch. Or we sometimes write that as PSI, pounds per square inch. And so that means that at sea level, that what you experience is so at sea level, then that means that every square inch has almost 15 pounds of pressure on it. Now, as you go higher in the atmosphere, remember the pressure depth relationship. Now, it's not quite as simple as just rho gh, because the density of air changes as you go, so you got to do an integral. So in that case, it'll be an integral of that. Okay, so in that case, what you'd have to do is you would imagine that the pressure would be integral rho g dx, okay, from 0 to h, where rho is actually now a function of the height. And so that turns out to be kind of complicated, but the higher you go, the less the pressure, because there's less air above you. And so as you go higher, you end up with a different pressure. And now that does change. The density of air changes. Density of air changes with humidity, with temperature. There's other factors that are involved in density of air. Air is real easy to compress. And so the pressure changes with the density. And so that means that now this is actually, an interesting thing about aircraft is, for an aircraft, you want to know how high your aircraft is above the ground. And so the way you do that is the aircraft doesn't just, you can't, airplane doesn't just lower a rope down to the ground to see how far it is. Okay. Modern aircraft, in principle, you could use radar to do this, but the radar is the low powered radar. When the aircraft is very high, then it's not going to work as effectively. And so what you want is some way of finding the altitude. And the way you do that is with an altimeter that really measures pressure. The altimeter in an aircraft is primarily a pressure measure. And so when a pilot is going to come in to land, they radio the tower at the airport, and the tower gives them the altimeter reading. Well, the altimeter reading is what you set the altimeter for. And so if the pressure here equals the pressure there, you're basically zero altitude. So you're right on the ground. Okay, and then as you go higher, the pressure drops off. So that's an example of the pressure depth relationship there. Another example of this pressure depth relationship is for a diver that's underwater. Okay, so you have a diver down here underwater, and we can put like scuba gear on him, so mask, bubble, bubble, bubble. Okay, so what happens is that atmospheric pressure at the surface is 1.013 times 10 to the fifth pascals. But as you go underwater some distance h, then now you have water pressure that's also equal to 1 atmosphere. So that means the total pressure, the pressure is going to be equal to the water pressure plus the atmospheric pressure that is above. Okay, so the question is, at what depth is the water pressure equal to 1 atmosphere? So the total pressure is now 2 atmospheres. Well, we know the pressure is rho gh. Okay, so h is going to be P over rho g. So 1.013 times 10 to the fifth pascals divided by the density of water is 1,000 kilograms per cubic meter, 9.81 meter per second squared. And so that comes out to be 10.3 meters. So at a depth of 10.3 meters, the pressure is 2 atmospheres. Okay, so that's 10.3 meters. If you go all the way down to 30.9 meters, that's like almost 100 feet underwater, then what happens at that depth is that at that depth, then the total pressure is going to be 3 atmospheres of water pressure plus an atmosphere of air pressure. So the total pressure is going to be 4 atmospheres. Okay, so now what that means is that up here at the surface, if you inhale air, okay, it's coming in at 1 atmosphere. Now, if you're underwater at a depth here of 10.3 meters, so about 31 feet down or so, 31 or 32 feet down, then what happens is that you cannot breathe because you'll have about 15 pounds of pressure for every inch on your chest. And so look how many inches across your chest is, and that much pressure, hundreds and hundreds of pounds of pressure keeping you from breathing unless you increase the pressure. So you have to increase the pressure. Well, we know that PV equals NKT, assuming you change, say, the same temperature, assuming that the volume of your lungs is the same. Increasing the pressure means an increase in the amount of air. So that means that if you have double the pressure, which is what you need to compensate for the water pressure, that means each breath takes in twice as much air as at sea level. When you're down at this depth, each breath takes in 4 times as much air. So that means you can't stay at that depth for very long because you end up using an awful lot more air. And so that's the idea here. The divers have to take extra tanks with them down here. And the other thing is you can't come up too quickly because your body is now pressurized at that level. So as you come up, you have to get the air which is dissolved into your blood out. Now the way your body works is oxygen and carbon dioxide very, very quickly cross the air-blood boundary in the lungs, and so you equilibrate there, but nitrogen doesn't. You are not a creature designed for changes in pressure. Birds, whales, things like that are more designed for changes in pressure than you are. You're designed to stay at roughly the same pressure and change very slowly, but basically as quickly as you can walk up a hill or something. And so what happens is if you come up too quickly, the pressure out on your lungs is going to rapidly get to the hundreds or thousands of pounds of force, and you can actually be injured or kill yourself coming up. Okay, unless you depressurize. Well, you can't depressurize too quickly because the nitrogen won't actually come out of solution in your blood very quickly. And so that means that it'll come out of solution in your blood as little bubbles. And those bubbles can be trapped, and it can do two of things. It can be like extremely painful and actually cause damage to your joints, or it can just kill you. And so neither solution is actually very, very pleasant. And so you don't want to come up too terribly quickly. And so this is basically how this pressure-depth relationship works in diving. The other thing that relates to this is if you have a water well, and so you drill a well and you put a pump up here and you want to suck water up from below. Well, that means you got some pressure down here that's pushing up. You got air pressure pushing down. So if you reduce the air pressure, there's less pressure pushing down, more pressure pushing up, and so the water comes up. So the question is, how far up can you push the water? Well, what's the lowest pressure you can put in the air? 0. So that means if this pressure is like close to an atmosphere, it can push water up 10.3 meters. Okay, now this pressure is slightly over an atmosphere. It can press it slightly more than that, but it's not going to it's not going to push water up enormously more than that, which means that if you want to have a water well that's like 100 feet deep, then there's no way of sucking the water up. Instead, what you have to do is you have to lower the pump to the bottom of the well, and it pushes up. In fact, this is how most water wells work: is you have a submersible pump that you lower down into the ground. The same is for oil wells. Here in Texas, it's pretty routine that you see these oil wells where you see the big machines here and this pump that goes up and down. Well, this is not sucking water up. What happens is there's a long rod that comes down to plungers down here, and so this is going up and down as this lever goes up and down, and that's when it goes up, it's pushing oil up from below. And so so this depth can be extremely great right here. So that's how these rocker arm type oil pumps work. And of course, you know, for any submersible sort of system, if this rod breaks, you've lost your pump down at the bottom of the well. And so that basically is the end of the well. And so you need to be very careful with that.